Now let's get familiar with some of the key Spark terms that we shall be aware, so that whenever we are talking about Spark, we will mention these terms. RDD, we already discussed, it is a distributed collection of data. And then data frame also, as we talked about, it is an interface which is built on top of RDD, where the data is organized as columns and rows, similar to any table. And next thing which is new is a partition. So partition, it is a chunk of data which is distributed. Like we have terabytes of data and billions of rows. So that data will obviously be divided into some parts so that each and every part can be processed parallelly on different executors. So each and every part is called a partition. Next, let's understand what is a transformation. So let's say we have some data. So what exactly we want to do with that data, that is the transformation. So for example, our data, we may want to filter out some data based on some condition or join them together like based on some column. We may want to do sorting or do a distinct on the entire data set. So basically whatever we want to do with our data, that is called as transformation. And the next thing is action. Let's say we have some operation or transformation which we want to do with the data, but finally what action we want to take, like whether we want to show the data back to us or we want to write the data to some location. So the final operation which shall happen to the data or the main output which is expected, that is called as action in terms of Spark. And the action, for example, it can be a show where the result will be shown to the user. It can be count where the result will be as a count, or write where the data will be written to some location that we specify. And there is one more important concept which is there in Spark. Let's say whatever we are doing with the data, performing any transformation or action. So until the point we are telling the Spark to do the transformation like filtering, union or any of the thing, Spark will actually not do the task on the executor. What it will do is it will create a mapping, let's say in his mind, like I need to filter out the data, then I need to do this, then I need to do this. So it will prepare some kind of a plan, but it will not run the job on the executors. When it will run the job, it is lazy, right? So whenever the final output is required, like the show or count or write, so that is when it will trigger the actual job on the executors. So that is why Spark is called as lazy, and this concept, it is called as lazy evaluation. And it is a very strong concept, I would say. Why? Because whenever we are telling the final action, then Spark will be able to decide like what exactly the job is required, and depending on the final output, I may skip some of the operation, or I may read the entire table, or I may read only one column. So all those things it decides when the final action is required, and that is why Spark is called as lazy, and this concept is called as lazy evaluation. There are two major categories of transformation which we shall be aware. One is called as narrow transformation. So in narrow transformation, each of the input partition, it contribute to only one output partition. So let's say we are doing some transformation from step 1 to step 2, and each partition, it is contributing to only one output transformation. So it can be 1 to 1 or many to 1 also. So in this scenario also, like each partition, it is contributing only to one output partition. So this type of transformation is called as narrow transformation. So in narrow transformation, either the number of partitions may remain same or they may reduce also, but they will never increase. The second type, it is the wide transformation, where each of the input partition, it may contribute to more than one partition. Let's say in this example, this partition, it is contributing to these two partitions. Similarly, here each partition, it is contributing to different multiple output partitions. So this is called as wide transformation, and in wide transformation the number of partitions may decrease, remain the same, or increase also. But the important point to note here is that one input, multiple output partitions. And that is where the data is shared between various partitions, and sharing this data across multiple partitions, that is called as shuffling. So this is also a very important term in Spark. So whenever shuffling will happen, the data will go from one executor to another executor, from there to another. So data will be shuffling a lot across those executors, and that is where whenever shuffling will happen, the job will take time. This is going to be a heavy operation, and normally we try to avoid shuffling wherever we can. So these are the two types of transformation, right? So narrow transformation, it can be, for example, a simple filter or union of two data sets, whereas wide transformation, it can be joining multiple data sets or sorting the data based on different column. So that is where shuffling will happen for sure.